Okay, so this lesson is 6-4. We are going to be solving disguised, oh Lord Jesus, disguised quadratics. Okay, so with that, our objective is to factor and solve polynomial equations. I'm going to abbreviate that. Polynomial equations that are quadratic in form. Okay, it's also known as disguised quadratics. Okay, so what's going to happen is these expressions and equations, they're going to actually look like quadratics, but they aren't quite. And I'm going to teach you a way of substitution that I know that on the college level, that's how they teach it. So that's what we're going to look at. So let's talk about factoring. So first we're going to factor. Okay, so what I have here is m to the fourth plus 9m squared plus 20. Okay, now what you'll notice is a disguised quadratic. You'll notice that the degree here, this first degree, this second degree, that it's basically 2 less than your first. So we had 4, 2, and then no kind of variable or anything like that. So that is going to be kind of a hint that this is a disguised quadratic. And it gets a bit more complicated at the college level. We're just going to take a simpler version of this. So my trick is, this is technically the quadratic term, this is my linear term, and then this is my constant, right? So what I'm going to do is I'm going to do a substitution, and typically at the university level they use u. U equals, and you're going to take your linear term, which is m squared. Okay? So we're going to substitute m squared with u for right now. Okay? So what I need to make note of is that m squared to the second power will give you m to the fourth. Okay? So I'm going to rewrite this thing real quick. This is m squared squared because m squared raised to the second power, 2 times 2 is 4. That gives you m to the fourth. Plus 9m squared plus 20. So what I now use is my substitution here, that u equals m squared. So wherever I see an m squared, I'm going to replace that with a u. So here I see an m squared, so we're going to do u squared plus 9u plus 20. So what I want to make very clear is what I wrote over here, that m squared to the second power gives you m to the fourth. I'm not doing any kind of voodoo or anything weird. What I'm doing is I'm just showing you an unsimplified version of m to the fourth, because m squared raised to the second power is m to the fourth. So now what I have is I have u squared plus 9u plus 20. So now I need to actually factor that. So I have u squared plus 9u plus 20. Okay, so I'm going to do my x factor. So if you thought factoring was gone, you are very wrong. So I have to think of two numbers that multiply to get 20 and add to get 9, and that'd be 4 and 5. Now notice, a is 1, so I can do my trick. U plus 4, u plus 5. Now, the very last thing that you actually have to do, remember how this was a substitution, u equals m squared? Now what I do is I go back and I put m squared back in for u. Okay? It's almost like you know, I mean, right now we've got the basketball season. You have your starters. You have the people who are going to start. But every now and again, they need a break. Or maybe they're getting too many fouls and they need to come out so they don't get fouled out or something like that. So you have a substitution that goes in. And that's what the U was for. That was our second set of legs and lungs and arms and all of that stuff to be able to make those 3-pointers and all of that. But then at the... after a while, that starter is going to go back in. So that's where the M squared comes back in. So, so kind of think of it, I guess, in sports terms, because a lot of times you sub out in sports. So then this is now completely factored. M squared plus 4 and M squared plus 5. Let's look at another one to factor. I have 7, oops, not you. I have 7x to the 4th plus 41x squared plus 30. Okay, so again, I need to do a substitution. So we're going to use U because that's typically what they use at the college level. And remember, I'm going to look at what my linear term is. My linear term, well, normally it's my linear term. Right now it's obviously quadratic because it's x squared. However, for our disguised quadratics, that would be where that linear term would be at, okay? So U equals x squared. So now I'm going to substitute anywhere I see an x squared, I'm going to use a U. Remember, x to the 4th is x squared squared, okay? So I'm going to have 7u squared plus 41u plus 30. Okay, so I did that substitution. So anywhere I saw an x squared, I substituted it with u. So now I'm going to do my x factors. So I have 41 and 7 times 30 is 210. So now I have to come up with two numbers that multiply to be 210 and add to give you 41. So this might take a couple minutes and that's okay. You get 35 and 6. So remember, a is not 1, so I have to do the long drawn out method. 7u squared plus 35u plus 6u plus 30. I need to then group them. None of this goes away, people. It stays with you forever. So I factor out that 7u because that was what was in common, and I get u plus 5. Over here with the 6u plus 30, 6 can be factored out, and I get u plus 5. So now I have 7u plus 6 times u plus 5. But I'm not finished because I have to substitute back in this guy here. We can't forget him. I'm going to go on to the next slide to substitute that x squared in for u. So we had 7u plus 6 times the u plus 5. So I just took it from here. Okay, and we remember that x squared equals u. So now where I see that u, I'm going to substitute it back in with an x squared. And now at this time, I have it fully factored. So now what we're going to do in the next part of the lesson is we're going to actually solve these. So this was just factoring and understanding the substitution. So then we're going to solve.